Our history books may be missing entire chapters of human ingenuity. This video explores 30 ancient sites where the evidence of advanced machining is carved directly into stone, challenging the official timeline of our past. By the end, you will see a clear pattern of impossible precision that forces a re-evaluation of what ancient cultures could truly achieve. How did builders in Bolivia cut granite with geometric perfection? And why do drill holes in Egyptian temples suggest the use of power tools? These stone puzzles point to a forgotten epoch of technical skill. What does it mean for our story if the ancients possessed knowledge we have yet to rediscover? High on the windswept Bolivian Altiplano, a landscape of stark beauty and thin air, lies a field of shattered stone that defies all conventional explanation. This is Puma Punku, a name meaning door of the Puma, and it looks less like a ruin and more like a factory floor struck by a cataclysm. Enormous slabs of red sandstone and andesite, some weighing over 100 tons, are scattered across the giant's careless hand. But it is not their size that shocks the observer, it is their condition. These are not rough-hewn boulders, they are precision-cut components, each one a masterpiece of geometric engineering. The stones feature razor-sharp right angles, flawless flat surfaces, and intricate channels carved with a consistency that looks machined. Among the most famous are the so-called H-blocks, which resemble massive, stylized letter H's. Each leg of these blocks has perfectly parallel grooves running along their length, grooves so uniform in depth and spacing they appear to have been milled by a modern router. The surfaces are smooth to the touch, with a finish that seems polished, not pounded. Archaeologist Arthur Poznański, who spent decades studying the nearby Tiwanaku complex, was among the first to publicly question how such work was accomplished. He argued the craftsmanship displayed a knowledge of geometry and a level of tool precision inconsistent with the simple bronze implements the Tiwanaku culture is known to have used. Perhaps the most compelling clue lies in the stones themselves. Several andesite blocks contain perfectly circular holes, bored straight into the incredibly hard rock. Some of these holes are shallow, but others are deep and uniform. Even more telling are the stone plugs, the cylindrical cores that were left behind when a drill was extracted. These cores are themselves perfectly round and smooth, showing the clear, spiraling groove of a drill bit that advanced through the stone with steady, relentless pressure. This is a signature of core drilling, a technique that requires a rigid, powered apparatus to maintain such consistent rotation and downward force. The question hangs heavy in the thin mountain air. How could a people from over 1,000 years ago, without hardened steel or modern power sources, achieve this factory floor precision on a monumental scale? The stones of Puma Punku offer no easy answers, only silent, impeccable testimony, setting a formidable standard as we begin our global search for the fingerprints of a lost technology. That signature of a spiraling drill groove is not unique to the high Andes. It reappears thousands of miles away, buried beneath the golden sands of Egypt. South of the Grand Temple complex at Abydos, a place of deep spiritual significance dedicated to the god Osiris, lies a structure that feels utterly alien to its surroundings. This is the Osireion, an enigmatic, sunken courtyard and hall that mainstream archaeology attributes to the pharaoh Seti I. But to walk from his beautifully carved sandstone temple into this subterranean space is to step into a different world and perhaps a different time. The Osireion is built on a titanic scale from massive blocks of red granite, a stone far harder than the sandstone used in the main temple. Colossal pillars, each weighing well over 100 tons, support equally immense lintels in a stark geometric design. The most striking feature is the joinery. These gigantic blocks are fitted together with tight, precise joints, assembled without the use of mortar. the surfaces are remarkably flat and smooth, bearing fine, parallel striations that run across the stone. To engineer and author Christopher Dunn, who has extensively studied ancient Egyptian stonework, these marks do not look like the erratic chiseling of bronze tools on unforgiving granite. Instead, they bear a striking resemblance to the uniform grooves left by a large, straight saw blade, a tool that would need to be harder than the granite itself to make such clean, consistent cuts. This presents a profound puzzle. Granite is one of the hardest stones on Earth. To shape it with such flatness and precision, to cut it into monolithic blocks and then dress its surface to a smooth finish, would require tools tipped with something like diamond or advanced abrasives, coupled with immense, stable mechanical force. The technology officially ascribed to Seti I's era simply does not account for this. The dissonance in style and technique has led many researchers to a compelling theory. Perhaps the Osireion is not a new kingdom creation at all, but a relic from a far older epoch. The later pharaohs, discovering this Cyclopean foundation, may have chosen to build their own temple complex above it, inheriting and sanctifying a site whose original builders and their methods had already faded into legend. The Osireion stands as a silent granite question mark, suggesting that the history of high-precision stonework is a thread connecting continents, a forgotten craft that once spanned the globe. From the sunken granite halls of the Osireion, the trail of precision descends even deeper into the very bedrock of Egypt. Beneath the sands of Saqqara, an ancient necropolis, lies a subterranean world of silence and staggering craftsmanship. This is the Serapeum, a labyrinth of long, straight tunnels carved through solid limestone. Here, in niches cut into the tunnel walls, rest objects that defy the imagination. 24 massive sarcophagi, each one carved from a single, solid block of rose granite. These are not ornate coffins covered in hieroglyphs. They are stark, minimalist boxes of immense weight and impossible perfection. The scale alone is humbling. Each box weighs an estimated 70 to 100 tons, the granite itself quarried from Aswan, over 500 miles to the south. But the true mystery is not their journey here, it is their finish. The interior of each box is a marvel of geometry. The corners are not merely roughly hewn, they are perfectly square, meeting at crisp 90-degree angles. The walls, floor, and ceiling inside are flawlessly flat and parallel to one another, with a surface polished to a glass-like reflective sheen. This is a level of precision that speaks not of hand tools, but of calibration. To achieve such perfect flatness and parallelism across such large interior surfaces would require a fixed point of reference, a stable guiding plane, concepts fundamental to modern milling machines. The final, breathtaking detail is the fit of the lid. Each monolithic lid, itself weighing many tons, was crafted to sit perfectly atop its box. The mating surfaces are so precisely machined that they create an airtight seal. It is often noted that you cannot slide a piece of paper or even a razor blade into the seam between the lid and the box. This is a feat of joinery that eliminates any margin for error. Officially, these boxes are attributed to the sacred Apis bull cult, serving as eternal resting places for the mummified bulls. Yet, this cultural purpose does not explain the manufacturing method. The accepted toolkit of the time, copper chisels, stone hammers, and abrasive sand, is utterly inadequate for the task. Copper is softer than granite. It would simply dull against it. Shaping, hollowing, and achieving a mirror polish on this scale with such primitive tools is a physical paradox. The boxes of the Serapeum stand as silent, polished enigmas. They were clearly made for a purpose, but the technology required to create them points to a sophistication that history has forgotten, leaving behind only these perfect, empty vessels in the dark. That same whisper of a machine's touch echoes within the grandest temple complex ever built. At the Temple of Karnak in Luxor, a sprawling city of stone dedicated to the god Ammon, the evidence is not in a finished masterpiece, but in a discarded one. Among the ruins lies a massive drum column of red granite, a cylindrical section intended for a towering pillar. It was abandoned, perhaps due to a flaw in the stone, but its unfinished state offers us an unparalleled glimpse into the process of its creation. On its surface is a deep, circular depression, the beginning of a drill hole meant to hollow out its core. This is no simple indentation. Inside the hole, carved with perfect clarity into the unyielding granite, is a continuous, uniform spiral groove. This groove tells a specific story. It is the unmistakable signature of a drill bit that fed into the stone at a steady, relentless pace, removing material with a smooth, mechanical efficiency. Modern engineer Christopher Dunn, who has meticulously studied this artifact, performed calculations based on the groove's pitch and the hardness of the granite. His analysis suggests the drill that made this mark would have required a downward pressure of several tons. Furthermore, the consistency of the groove indicates the drill was rotating at a high and stable speed. This changes everything we think we know. A common bow drill spun by hand could never achieve this. The pressure would stall the rotation. The irregular motion would create a jagged, uneven hole. This Karnak core sample points to something else entirely, a powerful, rigid machine. Imagine a drill press of monumental scale, a stable platform that could apply immense, controlled force while spinning a cutting head at hundreds, perhaps even thousands, of revolutions per minute. The implications are staggering. It hints not at artisans laboring for years with simple tools, but at a sophisticated workshop equipped with advanced machinery, a place where granite was shaped not through endless toil, but through applied mechanical power. This single, abandoned drum column is a frozen moment in that workshop's operation, a direct imprint of a technology that our history books have yet to acknowledge, leaving its only resume carved in stone. The spiral groove in the Karnak granite is a whisper of power, but high in the Peruvian Andes, an entire fortress shouts its impossibility. Perched on a steep ridge overlooking the ancient Incan capital of Cusco, Sacsayhuamán is a monument of staggering scale and bewildering precision. Its defining feature is a series of 3 zigzagging defensive walls built from colossal blocks of limestone, some weighing over 120 tons. These are not simple stacked rectangles. The stones are polygonal, meaning they have multiple sides, and they fit together in an intricate, interlocking jigsaw puzzle that has withstood centuries of earthquakes. The true marvel is in the joints. Each massive block was shaped to nest perfectly against its neighbors, with seams so incredibly tight that, as with the Serapeum boxes, not even a razor blade can be inserted. This is not just careful craftsmanship, it is a level of precision that implies a master plan, a system of measurement and fitting that borders on the obsessive. But the mystery deepens when you look closer. The surfaces of these giant stones are not flat. Many feature subtle, rounded bulges or gentle depressions. This is not erosion or damage. It appears to be intentional. These convexities and concavities mean that each block had to be shaped in 3 dimensions, a sculptural feat requiring a profound understanding of geometry and form. How could a culture without the wheel, without iron, and supposedly using only stone hammers and bronze tools, achieve this? The conventional explanation of patiently pounding stones with harder stones seems woefully inadequate to account for such seamless, complex joins. Some researchers have proposed extraordinary methods. One theory suggests a process of vitrification, where the stone surface was somehow temporarily softened or made malleable, perhaps through intense heat or a chemical agent, allowing it to be molded into place. Another, more speculative idea points to the use of sonic or vibrational tools, frequencies that could resonate with the stone and allow it to be shaped like clay. While these ideas venture into the unknown, they highlight the sheer perplexity of the construction. A more grounded, yet still advanced, theory involves the use of sophisticated template systems. Imagine craftsmen creating precise, three-dimensional models or patterns for each unique stone. A master template, perhaps made of wood or clay, would allow workers to transfer complex shapes onto the raw limestone blocks with a high degree of accuracy. This still requires incredible skill and organization, but it moves the achievement from the realm of magic to that of advanced, systematized engineering. Whether through forgotten chemistry, resonant sound, or meticulous templating, Sacsayhuamán stands as an Incan masterpiece that transcends conventional history. It represents a deep, intimate dialogue with stone, a knowledge so complete that these giants were persuaded to embrace one another, forming a wall not just of rock but of a seamless, silent mystery. The seamless joins of Sacsayhuamán speak of a deep understanding of stone, but at another Peruvian site, the stone itself seems to tell a different story. In the heart of the sacred valley, the fortress and temple complex of Ollantaytambo rises in majestic terraces against a steep mountainside. This was a stronghold, a royal estate, and a marvel of Incan engineering. Yet scattered amongst its classic, finely fitted walls are stones that feel like anomalies. These are massive blocks of pink porphyry, a spectacularly hard type of igneous rock. Their surfaces are not simply flat, they are etched with strange, precise features. You can see long, straight channels cut into the stone, grooves that run with ruler-like precision. Some are shallow and wide, while others are narrow and deep, and many have perfectly flat bottoms and crisp 90-degree corners. To the modern eye, they look exactly like the tracks or guideways you would find in industrial machinery. What were they for? Mainstream archaeology offers practical theories. Perhaps they were part of an intricate water drainage system, channels to direct rainfall from the sacred platforms. Another compelling idea is that they once held metal clamps, used to bind adjacent stones together, a technique seen in other ancient cultures. But the purpose is not the deepest mystery here. It is the execution. Creating such features in pink porphyry is an immense technical challenge. This stone is brutally hard, far tougher than granite. To cut a long, straight channel into it with a flat bottom and sharp internal corners using only stone or bronze tools would be a task of almost unimaginable difficulty and time. The result would likely show the telltale signs of handwork: slight wobbles in the line, a rounded or uneven bottom, a gradual taper. Yet the channels at Ollantaytambo show none of this. They are flawlessly straight, smooth, and uniform. This precision implies the use of a guided tool, something that could maintain a fixed path and depth with mechanical consistency. It suggests a process more akin to milling or routing than to chiseling. The logistical puzzle only deepens the enigma. The quarry for these unique pink porphyry blocks is not on the mountain. It is located across the valley on a hillside high above the opposite bank of the Urubamba River. Transporting these multi-ton blocks down a steep slope across a rushing river and then up the valley to the construction site is a feat that strains belief, even for the renowned Incan road and transport systems. When you stand before these stones, you are faced with a cascade of questions. How were they moved? More importantly, how were they shaped with such ease and accuracy? The channels cut into the pink porphyry of Ollantaytambo are not just architectural features. They are like frozen diagrams, technical drawings left in stone, hinting at a method of working with the hardest materials that we have yet to fully comprehend. Descending from the fortress walls of Sacsayhuamán into the very heart of the old Incan capital, you find the spiritual center of their empire. The Coricancha, or Temple of the Sun, was once sheathed in gold, a dazzling tribute to the most revered deity in the Incan world. That precious metal is long gone, but what remains beneath is arguably more valuable to our understanding. It is the foundation, the original stonework upon which the Spanish later built the Church of Santo Domingo. This surviving base is a quiet, breathtaking lesson in stone. Here, the masonry reaches an almost artistic level of complexity. The stones are not rectangular blocks, but polygonal masterpieces, each one a unique shape with multiple sides and angles, fitting together in a giant, three-dimensional jigsaw puzzle. The joints are not straight lines, but intricate, zigzagging seams where one stone embraces another with a geometric intimacy that seems impossible. To achieve this, the builders would have needed more than skill, they would have needed a plan. Each irregular stone had to be shaped to match the precise, negative space of its neighbors. This implies a level of drafting and geometric foresight that rivals modern engineering. They were not simply stacking rocks, they were solving a spatial equation for every single block, ensuring that the angles and faces would align perfectly across the entire wall. The result of this painstaking calculation is a structure of legendary resilience. Cusco sits in a highly active seismic zone, and the city has been shaken by powerful earthquakes that have toppled colonial buildings erected on top of these ancient walls. Yet the original Incan foundations of the Coricancha have not budged. They move as a single, flexible unit, the interlocking stones shifting slightly during a tremor before settling back into their perfect alignment. This is earthquake engineering carved in stone, but the mystery extends beyond the fit to the finish. The surfaces of these polygonal stones are smoothly polished, presenting a uniform face to the world. To the naked eye, there are no visible tool marks, no scars from hammer stones or chisels. This suggests a final finishing process that went beyond cutting. It points to a grinding or polishing technique capable of achieving a near-industrial flatness across large, irregular surfaces. How was this done? The absence of marks is itself a clue, hinting at a method that removed material evenly, perhaps with a specialized abrasive slurry and a great deal of time and pressure, effectively lapping the stone to a flawless plane. The Coricancha foundation represents the pinnacle of this stone-fitting technology. It is not just a wall, it is a testament to a philosophy of construction where precision was the ultimate form of strength and reverence, a puzzle solved with what looks, to our modern eyes, like the patient, calibrated precision of a master machinist. But the pinnacle of stonework in the Americas still pales before a sight of truly incomprehensible scale. In the Bekaa Valley of Lebanon, the ancient complex of Baalbek presents a megalithic puzzle that dwarfs all others. Here, the Romans constructed a magnificent temple to Jupiter atop a pre-existing platform of staggering proportions. The most famous feature of this foundation is the Trilithon, a row of 3 colossal limestone blocks forming part of the temple's western retaining wall. Each one of these stones is a behemoth, measuring roughly 64 feet long, 14 feet high, and 12 feet deep. Their weight is estimated at 800 tons apiece. To visualize that, imagine 3 fully loaded jumbo jets, each carved from a single piece of stone, and then lifted over 20 feet into the air to be fitted seamlessly into a wall. The engineering required to quarry, transport, and position these blocks is a subject of intense debate and awe. Yet, the true mystery is not just their movement, but their preparation. The mating surfaces where these giants meet are not rough or uneven. They are precision-dressed, flat and true over their entire vast area, allowing them to sit in near-perfect alignment. Achieving such flatness across an 800-ton block is not a matter of brute force. It is a delicate operation of leveling and surfacing that implies the use of sophisticated guiding systems and measurement tools. The puzzle deepens just a short distance away in the quarry. Here lies the stone of the pregnant woman, an even more massive monolith partially cut from the bedrock. This block is estimated to weigh over 1,000 tons, making it the largest known worked stone from the ancient world. It was cut, shaped, and prepared for transport, but for reasons lost to time, it was never moved. Its very existence raises a profound question. If this 1,000-ton stone was the intended sibling for the Trilithon blocks, what does that say about the ambitions and capabilities of the builders? The Romans are credited with the temple above, but the origins of this Cyclopean platform are far older, potentially dating back millennia before their arrival. The precision of the foundational stonework suggests its creators possessed not just immense manpower, but a masterful understanding of engineering principles, knowledge of leverage, bearing, and alignment that goes far beyond simple ramps and ropes. To shape the contact points of these titans, to ensure they would bear the unimaginable weight of the structure above without shifting, required a level of planning and execution that feels, even today, almost superhuman. Baalbek stands as a monument to scale so vast it bends the mind, a place where the stones themselves ask us how, and more importantly, who. Yet the scale of Baalbek is matched by a site of profound subtlety, one that lies not on a mountain but beneath the sea. In the clear, turquoise waters off the coast of Bimini in the Bahamas, a formation stretches across the ocean floor that has divided opinion for decades. Known as the Bimini Road, it appears as a long, straight pathway of rectangular limestone blocks, resting in shallow water just a few meters deep. To the casual glance, it might resemble a natural formation of fractured beach rock, a geological oddity. But a closer look reveals a pattern that feels stubbornly deliberate. The blocks are remarkably uniform, many featuring sharp, 90-degree corners and parallel sides. Some stones are arranged in a distinct J-shaped curve, an alignment that seems less like random breakage and more like intentional design. On the surface of several blocks, investigators have noted what look like linear grooves and small, circular pinholes, marks that some argue resemble the effects of tools rather than natural erosion. If these features are indeed artificial, the precision of the shapes implies a process beyond simple quarrying. It suggests the blocks were cut, dressed, and perhaps even fitted, using techniques that would leave clean angles and flat surfaces. The greatest mystery, however, is not their shape but their location. The Bimini Road is submerged. Geological studies of sea level rise indicate this area would have been dry land, a coastline, thousands of years ago. This places its construction, if it is construction, in a deep and foggy antiquity, potentially long before the rise of any known seafaring culture in the region with the capability for such stonework. The site sits at the heart of a much larger narrative, one that speaks of a time when the geography of our world was dramatically different. It raises a haunting possibility. Could this be a fragment of a lost landscape, a single paved path that once led somewhere, now claimed by the rising waters at the end of the last ice age? Whether a marvel of natural geology or a relic of a forgotten civilization, the Bimini Road serves as a silent, sunken question mark. It asks us to consider not just how such stones were shaped, but when, and for whom, in an epoch when the shorelines of history were drawn in a different place entirely. Far from the sunlit shallows of the Bahamas, in the deep, powerful currents of the East China Sea, lies a structure that makes the Bimini Road seem like a sketch. Off the southern tip of Yonaguni Island, Japan, the seafloor drops away to reveal a colossal formation that has ignited one of the most passionate debates in underwater archaeology. This is the Yonaguni Monument, a massive, tiered complex of sandstone that rises from the depths like a sunken ziggurat. Its most striking features are its stark, geometric lines. You can see broad, flat terraces that drop in clean, horizontal levels. There are sharp, vertical cliffs that meet the seafloor at what appear to be perfect 90-degree angles. One prominent feature looks like a giant staircase with steps of uniform height and depth. The surfaces of these formations are not rounded and eroded by the sea, as you might expect. They are planar with long, straight edges and crisp corners that seem carved by intent. Marine geologists like Professor Masaki Kimura, who has studied the site for decades, point to the area's unique sandstone, which naturally fractures along horizontal and vertical planes due to tectonic stress. They argue that the relentless sculpting force of ocean currents could, over millennia, have exaggerated these fractures into the astonishing shapes we see today. It is a compelling natural explanation, yet standing in opposition to this view is the sheer, overwhelming regularity of the forms. The human eye is trained to recognize design, and Yonaguni screams of it. In several locations there are what look like carved channels, straight grooves that run across the rock. There is a distinctive triangular depression, and two round holes aligned next to each other that seem too symmetrical to be random potholes. If these features are natural, they represent a 1 in a million geological coincidence. If they are artificial, the implications are staggering. Constructing such a monument would have required a society capable of organized labor on a massive scale, not on land, but in a challenging underwater environment. This suggests not just stone working skills, but potentially diving and underwater construction techniques. More fundamentally, it would demand tools that could make precise, linear cuts in solid sandstone beneath the waves. The timeline adds another layer of mystery. Sea level data indicates this area was last above water around 10,000 years ago, at the end of the last ice age. If human hands shaped Yonaguni, they did so in a prehistoric epoch, long before the rise of any known Pacific civilization capable of such an undertaking. The monument sits on the knife's edge between geology and history, a silent, submerged sentinel guarding a secret. Is it a masterpiece of natural forces, or the drowned architecture of a forgotten world? The answer may lie not in choosing one side, but in questioning whether our current understanding of nature and of human history is complete enough to explain the perfect angles in the deep. While Yonaguni's perfect angles lie submerged, another ancient site sits high on a barren Turkish hilltop, its stones carved not by water but by a forgotten human hand. Göbekli Tepe is a place that shatters timelines. Constructed over 11,000 years ago, it predates Stonehenge by 6 millennia and the Great Pyramids by 7. This is not a settlement or a city, but a series of circular enclosures built around massive, T-shaped limestone pillars. Each pillar is a monolith quarried from a nearby bedrock source, shaped and then transported to this hilltop sanctuary. The animal carvings that adorn them, foxes, boars, cranes, and lions, are breathtaking in their detail, a gallery of wild art from the dawn of civilization. Yet the true mystery is not the art but the canvas. Look past the reliefs to the pillars themselves. Their surfaces are smooth, their edges are straight, and their distinctive T-shape is replicated with remarkable consistency across dozens of these multi-ton stones. This uniformity is the silent clue. In an era officially defined by small, nomadic bands of hunter-gatherers using simple flint tools, how did they achieve this? Creating such massive, identical forms requires more than artistic vision. It demands systematic production. It implies a template, a shared mental blueprint that every craftsman followed. The clean lines and symmetrical shapes suggest the use of specialized tools beyond crude hammerstones. Researchers have proposed the use of finely crafted flint bearings and scrapers, used with a technique of persistent, controlled abrasion. But to shape hard limestone into these precise, monolithic forms would have required not just skill, but an organized labor force with a deep, accumulated knowledge of stone. Someone had to manage the quarrying, oversee the shaping, and coordinate the transport of these pillars, each weighing many tons, up the hill without the wheel or domesticated animals. Göbekli Tepe forces us to reconsider the very definition of primitive. It presents a profound paradox, a society sophisticated enough to execute monumental architecture, yet one that left no evidence of agriculture, permanent dwellings, or writing. The pillars stand as a testament to a different kind of advancement, one rooted in shared belief and a technical mastery of stone that we are only beginning to understand. They are the manufactured bones of a ritual world, proof that precision and the drive to create something enduring from the earth may be far older than we ever dreamed. The drive to shape stone into meaning finds one of its most isolated expressions on a remote volcanic island in the vast Pacific. Easter Island, or Rapa Nui, is famous for its enigmatic moe, the towering stone sentinels that gaze inland from coastal platforms. But to understand their creation, you must journey to the source, the volcanic crater of Rono-Roroku. This is not merely a quarry, it is an open-air factory frozen in time. Scattered across the inner and outer slopes of the crater are hundreds of statues in every conceivable stage of completion. Some are just outlines sketched onto the bedrock, while others are nearly free, connected only by a thin spine of rock along their backs. Walking among them is like stepping onto a workshop floor where the workers have just stepped away. The finished moe that were transported across the island display smooth, curved planes, from the arc of a brow to the subtle swell of a torso, and facial features carved with a consistent, stylized precision. This uniformity across hundreds of statues is the first clue to a systematized process, but the true technical mystery lies in the details of the unfinished work. On several partially carved moe and on the crater walls themselves, you can find curious, perfectly cylindrical holes. These are not random pits or fractures. They are clean, round drill marks, often several inches deep, bored straight into the volcanic tuff. Researchers have proposed these holes served a critical function in the manufacturing process. One leading theory is that they were used for a technique called wedge and feather splitting. Workers would drill a line of these parallel holes, then insert dry wooden wedges into them. When water was poured over the wood, the wedges would swell with tremendous, even pressure, creating a controlled fracture that would split the stone along a straight plane. This method would explain how the Rapa Nui could so cleanly separate a multi-ton statue from the living rock of the crater wall. The consistency of these holes, however, tells a deeper story. Their uniform diameter and depth suggest the use of a standardized drilling tool, a repetitive implement that could produce the same result over and over. This might have been a simple hand-operated drill with a hardened stone bit, but its repeated, precise application represents a form of primitive machining. It was a technology of replication, allowing a community to produce their iconic giants not as one-off artistic endeavors, but as a series following a shared template with remarkable efficiency. The silent factory of Rono-Roroku thus reveals a dual legacy, a profound spiritual expression carved into the landscape, and a quiet, practical ingenuity evidenced by those perfect, purposeful holes, the mechanical fingerprints left behind by the makers of giants. From the sunlit quarries of Easter Island, we descend into a world of perpetual twilight and astonishing foresight. Deep in the heart of Turkey's Cappadocia region, beneath a landscape of fairy chimneys and carved rock dwellings, lies an underworld of staggering complexity. This is the Derinkuyu underground city, a labyrinthine refuge carved not from hard granite but from soft volcanic tuff. While this rock is more yielding to the chisel, the achievement here is not the material's hardness, but the sheer, systematic ambition of the excavation. This is not a simple cave system or a few hidden rooms. It is a vertically organized metropolis capable of sheltering thousands, complete with living quarters, stables, churches, wine presses, and communal kitchens, all stacked across multiple levels descending hundreds of feet into the earth. The softness of the stone made carving possible, but the precision of the work made the city livable and defensible for extended periods. Look at the ventilation shafts, for instance. These are not rough holes, they are perfectly circular ducts, some measuring over 3 feet in diameter, that plunge straight down through multiple floors to the deepest chambers, providing a steady flow of fresh air to an entire subterranean population. Maintaining such a perfect cylindrical bore over such a great depth, ensuring it remained plumb and true as it passed through different levels, is a feat of engineering surveying. It implies the use of measuring tools like plumb bobs and levels, and a coordinated plan that was followed with remarkable discipline. The living spaces themselves show a deliberate, almost modern sensibility. Rooms have smooth, flat walls and ceilings, with corners meeting at clean angles. The passages and stairways that connect the 18 explored levels are not meandering tunnels. They align with a consistent width and gradient, designed for controlled movement and security. Narrow, sloped corridors could be sealed at a moment's notice with massive, circular stone doors, each perfectly shaped to roll into a recessed slot in the wall. This level of integrated design points to more than people hacking out spaces with hand picks. It suggests the use of guided boring equipment, perhaps simple but effective frames or templates, to maintain level and direction through the soft rock. The entire complex speaks of a master blueprint, a premeditated vision executed with the patience and precision of a master clockmaker, but on a scale of geologic architecture. Derinkuyu is a monument to communal survival, a fortress carved not upward toward the sky, but downward into the safety of the earth, showcasing a form of subtractive machining applied to an entire hidden landscape. The hidden cities of Cappadocia reveal a mastery of carving inward, but on the sun-drenched plains of Costa Rica, ancient artisans pursued a different geometric ideal, outward perfection. Scattered across the Diquis Delta, often half buried in the soil or standing silent in village squares, lie hundreds of stone spheres. These are not rough, round boulders. They are meticulously crafted orbs, some small enough to hold in your hands, others colossal, measuring over 2 meters in diameter and weighing many tons. The material itself is a key part of the mystery. They are carved from gabbro, a hard, dense, igneous rock related to basalt, a stone that is notoriously difficult to shape. Yet, the artisans of this pre-Columbian culture achieved something that seems to defy the tools of their time. The sphericity of these objects is not merely approximate, it is astonishingly precise. Modern measurements of the most intact spheres have revealed deviations of only a few millimeters from a perfect geometric sphere. To put that in perspective, across a surface the size of a small car, the variation is less than the thickness of a coin. Achieving this level of uniformity without the benefit of modern lathes, laser scanners, or precision calipers is a profound puzzle. The accepted theory for their creation involves a multi-stage process of pecking and grinding. Workers would first rough out a spherical shape from a suitable boulder using hammerstones, then gradually refine it by grinding the surface with abrasives like sand, perhaps using the stone itself as a tool against another rock. But the final stage, the polishing, is where the mystery truly deepens. To take a rough ball of gabbro and polish it into a near-perfect sphere requires more than patience. It demands a sophisticated, intuitive understanding of geometry and a method for removing material evenly from every single point on the surface. This is, in essence, a machining process. It implies a technique for constantly checking and correcting the form, ensuring that no one area was ground down more than another. Some researchers suggest they may have used a system of cords or frames to measure diameters from multiple points, a slow, painstaking form of three-dimensional calibration. The purpose of these spheres adds another layer of intrigue. Found near chiefly residences and in alignments, they are thought to have held great social and symbolic importance, possibly representing celestial bodies or markers of status and authority. Their silent, perfect forms stand as a testament to a culture that valued an abstract ideal of geometric purity, investing untold labor to transform the hardest stone into objects of flawless, mysterious beauty, a quiet echo of the sphere-making we would only rediscover with the dawn of the machine age. The quest for geometric perfection now takes us to a city that seems to float upon the sea. In the western Pacific, on the island of Pohnpei, the ruins of Nan Madol rise from a shallow lagoon like a ghostly, misplaced Venice. This is not a city built on solid ground, but a network of over 100 artificial islets constructed atop a coral reef, all connected by a maze of tidal canals. The scale is staggering, but the building material is what truly captivates. The entire city is assembled from colossal logs of basalt. These are not rough stones, however. They are prismatic columns, a natural geological wonder formed when thick lava flows cool and contract, cracking into spectacular, multi-sided pillars. Nature provided the raw material, but human hands performed the precise surgery. Each of these basalt logs, some weighing many tons, was meticulously cut to a specific length. If you examine the ends of these columns where they meet, you will find they are not jagged or broken. They have been dressed, flattened to create a smooth, even contact surface so they can stack securely. The builders employed a clever crisscross pattern, laying long columns as foundations, then stacking shorter ones atop them in alternating layers, creating remarkably stable walls without any mortar. This precise cutting is the core of the mystery. Basalt is an extremely tough, dense volcanic rock. To cut through these massive columns cleanly to create a straight, flat break requires more than brute force. It implies a controlled technique. One compelling theory involves a method of thermal shock. Workers may have built a hot fire along a desired fracture line, heating the basalt intensely, and then rapidly dousing it with seawater. The sudden, extreme temperature change would create immense stress, causing the rock to fracture cleanly along the heated zone. This is a sophisticated understanding of material science, a way of persuading the stone to break exactly where you want it to. But the puzzle does not end at the quarry. These multi-ton logs had to be transported from the volcanic interior of the island, through dense jungle and tangled mangrove channels, out to the reef construction site. The logistical coordination alone speaks of a highly organized society with advanced knowledge of buoyancy and leverage, perhaps floating the columns on rafts during high tide. Nan Madol stands as a testament to a unique marriage of natural form and human intention. The builders did not fight the stone's inherent geometry. They harnessed it, using precision cutting to transform nature's pillars into the bones of a city that still whispers from its watery grave, a marvel of engineering that turned a reef into a kingdom. Those few surviving casing stones at the Giza Plateau hold a secret far more precise than the pyramid's famed alignment. While the Great Pyramid's core is a mountain of rough-hewn blocks, its original skin was something else entirely. It was once sheathed in over 5 million square feet of brilliant white Tura limestone, quarried from across the Nile. This gleaming shell transformed the structure from a colossal pile of stone into a perfect geometric form, a smooth-sided mountain that reflected the sun with blinding intensity. Today, only a handful of these original casing stones remain, mostly at the base, protected by the very rubble that once covered them. And it is here, at the foot of this ancient wonder, that we find evidence not just of grand scale, but of microscopic perfection. The joints between these multi-ton limestone blocks are not merely tight, they are almost invisible. The gap is often less than the thickness of a credit card, a space so minute that it challenges our understanding of ancient masonry. But the true marvel is the surface of the stones themselves. They are not just flat, they are optically flat. When you place a straight edge against them, there is no light that passes between the metal and the stone. The corners are not rounded or chipped but sharp and true, meeting at crisp 90-degree angles. This is a level of precision we associate with modern machine shops, not with Bronze-Age chisels and sand abrasives. Achieving such a finish on a single block is a master craftsman's work. Replicating it across tens of thousands of blocks, and then fitting them together on a curving surface over 400 feet in the air, is an engineering miracle. It suggests a process beyond hand dressing. The uniformity points to systematic grinding or milling techniques, where blocks were brought to a final, identical specification using guided equipment that could ensure planar perfection. Some researchers have even proposed that the final polish was achieved with a slurry of fine abrasive and water, using the stones themselves in a lapping process to create that legendary, mirror-like sheen. This transforms our mental image of the pyramid. It was not a rough stone monument, but a gigantic, machined reflector. At dawn, its eastern face would catch the first rays of the sun, a beacon of polished geometry announcing the pharaoh's eternal connection to the celestial order. The few remaining casing stones are therefore more than just architectural remnants. They are silent witnesses to a lost finishing technology, a clue that the builders of Giza possessed not only the strength to move mountains, but the delicate touch to dress them in light. Yet that same whisper of the machine is found not in the pyramid's skin, but in its shadow. Adjacent to the silent gaze of the Sphinx lies the Valley Temple, a structure of profound and understated power. While often overshadowed by its more famous neighbors, this temple is a masterclass in megalithic engineering and a repository of tantalizing clues. Its lower courses are constructed from enormous blocks of red granite, each a titan weighing well over 100 tons, quarried from a swan hundreds of miles to the south. Like the stones at Baalbek, their sheer mass is a logistical puzzle, but it is their assembly that truly captivates. These colossal blocks are not simply stacked. They are interlocked with a joinery so precise it feels like a cabinetmaker's work, executed on a scale for giants. The seams are tight, the alignments flawless, creating a foundation of unmovable solidity. But to understand the method, you must step inside, away from the desert sun. In the dim, cool interior, run your hand along the walls of red granite. The surface is not featureless. Etched into the stone are long, straight grooves, tool marks that run parallel to each other with a mechanical regularity. These are not the chaotic, multidirectional scars left by pounding stone or chiseling with a soft copper tool. They are uniform, evenly spaced lines that look for all the world like the feed marks left by a large, straight saw blade. This visual signature is critical. Granite is phenomenally hard, ranking high on the Mohs scale of mineral hardness. The copper tools available to the dynastic Egyptians are significantly softer. The conventional explanation involves using a copper saw with an abrasive slurry of quartz sand. In theory, the sand does the cutting, not the copper. But this method is wildly inefficient for deep, linear cuts in such a resistant material. It would be a process of agonizing slowness, prone to creating irregular, wavering grooves as the saw inevitably bent and wandered under pressure. The marks in the Valley Temple do not show this. They are straight, deep, and parallel, suggesting the cutting tool itself was rigid enough to maintain a perfect line and hard enough to guide the abrasive with unwavering consistency. This discrepancy has led researchers to propose extraordinary alternatives. One theory speculates about the use of lost alloys, metals harder than copper or even bronze, perhaps a form of tempered steel that history has not recorded. Another, more speculative idea ventures into the realm of vibrational or sonic technology. Could a tool have been used that did not grind, but rather resonated at a specific frequency, allowing it to separate the granite along a crystalline plane with minimal resistance? These concepts point toward a distant epoch of advanced technical knowledge. Whether through a forgotten metallurgy or a physics we are still relearning, the Valley Temple's granite walls stand as an interior record of a process that should not, by our current historical understanding, exist. They are the enduring scratch notes of a technology that shaped the very bones of the ancient world. Deep within the Temple of Seti I at Abydos, a place we have already visited for its stonework, the walls hold a different kind of puzzle. Among the intricate hieroglyphic inscriptions, a small cluster of carvings stands out for its bizarre, anachronistic appearance. To the modern eye, one looks unmistakably like a helicopter, complete with a rounded cockpit and a tail rotor. Another resembles a submarine or a tank, and a third brings to mind a futuristic aircraft. This is the famed Abydos helicopter glyph, and it has become a cornerstone for theories of ancient astronauts and lost high technology. The mainstream archaeological explanation, however, is both more mundane and fascinating in its own right. This is a classic case of a palimpsest in stone. Seti I began the inscriptions, carving his royal titles and epithets deeply into the wall. Years later, his son, Rameses II, partially chiseled out his father's work to re-inscribe the space with his own name and titles. This recarving did not perfectly erase the older glyphs. Instead, the overlapping lines of the two separate inscriptions, carved at slightly different angles and depths, merged to create these accidental composite shapes. The helicopter is not a single, intentional carving, but a chance visual echo born from two historical egos competing for immortality on the same stone canvas. Yet, even with this rational explanation, the conceptual mystery holds a powerful allure. It speaks to a deep human tendency to see our own world in the artifacts of the past. More importantly, the very existence of such a precise recarving process in this specific temple is telling. The artisans of Abydos were masters of stone, capable of meticulous, controlled removal of material to reshape a sacred text. This technical skill with carving and precision aligns with the other advanced stonework found throughout the complex. While the helicopter itself is an illusion, the culture that produced it was clearly steeped in a tradition of exacting craftsmanship. It is not a great leap to wonder if the myths and symbols they intentionally carved elsewhere, stories of gods traveling in solar barks through the heavens, might themselves be distant, mythologized memories of a different kind of technology. The real connection to our theme of machining, therefore, is not in the accidental helicopter, but in the context of its home. This temple, with its palimpsests and its precise joins, stands as a monument to a lineage of builders and priests who were custodians of sophisticated stone-working knowledge. In their drive to correct, update, and perfect the sacred walls, they demonstrated a level of control over their medium that feels, in its own right, remarkably advanced. The helicopter glyph is a Rorschach test, a stone-born coincidence that challenges us to separate our projections from the genuine and perhaps even more profound precision that surrounds it. The meticulous control over stone seen in the great temples finds its echo in a quieter, more domestic scale within the ruins of an ancient metropolis. In the dry plains of modern-day Pakistan, the Indus Valley city of Mohenjo-Daro rises from the dust as a testament to a forgotten urban genius. Its wide, grid-patterned streets and sophisticated drainage systems speak of a society built on order and standardization, most famously seen in their uniformly sized baked bricks. Yet, among these grand civic works, some of the most compelling evidence for their technical prowess is small enough to fit in the palm of your hand. Archaeologists have uncovered exquisite beads crafted from carnelian, a beautiful but notoriously hard form of quartz. These are not simple, rough ornaments. Many are long, slender cylinders, meticulously shaped and polished to a deep, translucent red. The true marvel, however, is hidden within. Running straight through the center of each bead is a perfectly cylindrical hole, a microtunnel drilled along the entire length of the stone. This is a feat that transforms a decorative object into a technical puzzle. Drilling such a long, straight, and uniform hole through a material as hard as carnelian is extraordinarily difficult even with modern electric tools. The Harappan artisans of Mohenjo-Daro achieved this over 4,000 years ago. The process would have required a drill bit harder than the quartz itself. Researchers suggest they likely used diamond-tipped drills, perhaps a sliver of natural diamond embedded in a copper rod, or an advanced abrasive technique employing a fine, hard powder. More than the material, though, is the method. To create that clean, consistent bore, the drill could not waver. It needed to be held in perfect alignment and rotated at a steady, controlled speed for an extended period. This points to the use of a simple but effective machine, a bow drill or a pump drill, a device that converts reciprocal motion into smooth, continuous rotation. This tool represents a fundamental principle of machining, the guided, mechanical application of force to shape a material with precision. These carnelian beads were more than just jewelry. They were products of a sophisticated lapidary workshop, a form of early micromachining that produced items of both stunning beauty and technical brilliance. They reflect a society that had mastered not only the macro scale of city planning, but also the micro scale of material science, leaving behind tiny, polished portals into a world of quiet, advanced skill. The micro-drilled beads of Mohenjo-Daro reflect a mastery of small-scale precision, but to see that same principle applied on a monumental scale, we must return to the high plains of Bolivia. The sprawling ceremonial center of Tiwanaku, a city that once rivaled ancient Rome in influence, presents a landscape of stone that feels engineered, not merely carved. At its heart stands the Colossal, a vast rectangular platform that served as an astronomical observatory and ceremonial stage. Its walls are constructed from enormous blocks of andesite, a volcanic stone even harder than granite. What immediately strikes you is the aesthetic of the place. There is a stark, modular quality to the construction, as if each block was a standardized component in a grand, pre-planned design. The stones are not irregular or organic. They are cut into clean, sharp-edged rectangles and squares fitted together with joints of breathtaking exactness. This is not the rustic stonework of a fledgling culture, but the output of what appears to be a highly organized industrial process. The famous Gate of the Sun, carved from a single block of andesite, is a masterpiece of this craft, its surface covered in intricate, low-relief iconography that is itself executed with a toolmaker's precision. But the real clues to their methods are found in the less celebrated stones. Scattered throughout the complex are blocks featuring curious, precise indentations. These are not decorative. They are carefully cut notches, T-shaped channels, and dovetail slots carved directly into the faces and tops of the megaliths. To researchers like engineer and author Jean-Pierre Protzen, who spent years studying Andean stonework, these features have a clear, functional purpose. They appear designed to hold metal clamps, likely made of bronze or a copper alloy, which would have been poured molten into the channels to bind adjacent blocks together. This technique, known as metal clamping, is a hallmark of advanced masonry, used to ensure seismic stability and permanent alignment. Yet at Tiwanaku, the clamps themselves are almost entirely absent, leaving behind only their negative spaces, empty sockets and channels that hint at a vanished technology. This absence speaks volumes. It suggests that the precision of the stonework was so complete, the fitting so perfect, that the primary purpose of the clamps may have been for assembly and alignment during construction, rather than permanent reinforcement. The entire site carries the aura of a kit assembled from prefabricated parts. Each andesite block, with its sharp angles, smooth faces, and prepared clamp channels, seems to have been manufactured to exact specifications in a centralized workshop, perhaps near the quarry, before being transported to the site for final assembly. This implies a level of organization that goes far beyond a team of stonemasons. It points to master architects working from detailed plans, using standardized templates to ensure every component would fit seamlessly with its neighbor. The stones of Tiwanaku are not just building blocks, they are fossilized instructions, a silent blueprint for a construction methodology that viewed mountain stone as a raw material to be milled, shaped, and assembled with the calm, confident precision of a master craftsperson. From the modular blocks of Tiwanaku, we journey to a place where the entire concept of construction is inverted. In the highlands of northern Ethiopia, the town of Lalibela is home to one of the most profound architectural wonders on Earth. Here in the 12th century, a king and his artisans did not build upward with stone, but downward into it. The result is a complex of 11 churches, each one not assembled, but revealed, carved directly from the living bedrock of a volcanic mountain. This is not architecture in the traditional sense. It is a form of spiritual excavation, a monumental act of faith made permanent in stone. To stand before the Church of St. George, perhaps the most iconic, is to witness a perfect cross-shaped form sunk deep into a square pit, its roof level with the surrounding earth. Every element, the walls, the windows, the decorative friezes, and the interior columns, is not an addition, but a part of the original, continuous rock. The precision of this subtractive process is staggering. Craftsmen began at the surface, outlining the entire perimeter of the church on the flat rock plateau. Then, with extraordinary patience and foresight, they began to cut downward, trenching deep moats around the planned structure to isolate a giant block of stone. Only then, with this monolith standing isolated in its own pit, did the true carving begin. From the top down, they hollowed out the interior spaces, shaping vaulted ceilings, arches, and sanctuaries from the solid mass. They carved intricate windows that let in geometric patterns of light, and detailed reliefs of biblical scenes directly onto the smooth interior walls. This is a process with zero margin for error. Unlike building where you can adjust, replace, or reposition a block, here every strike of the chisel was permanent. Removing too much material in one area could not be undone. This demanded a complete, three-dimensional vision held in the minds of the master planners before the first tool ever touched the rock. In modern manufacturing, this is called subtractive machining. You start with a solid block of material, a workpiece, and you use tools to remove everything that is not the final design. At Lalibela, the workpiece was a mountain, and the tools were the chisels, hammers, and unwavering faith of its creators. The sheer scale of removed material is almost incomprehensible, with thousands of tons of rock painstakingly quarried away to leave these hollow forms. The churches of Lalibela represent a machining mindset applied not to metal or wood, but to geology itself, a devotional act that transformed a plateau into a place of worship through the meticulous, reverent removal of stone. The silent, subtractive faith of Lalibela finds a stark, powerful echo in the sun-bleached stones of a much older citadel. In the rugged hills of the Greek Peloponnese, the Lion Gate of Mycenae stands as a sentinel from the heroic age. This is not a gate in the modern sense, but a monumental doorway into a fortress of legend, the home of King Agamemnon. Its construction is a masterclass in Bronze Age engineering, a deliberate step toward a new standard of precision. The gate's defining feature is the massive limestone lintel, a single block spanning the entrance and weighing many tons. What makes this lintel remarkable is not its size alone, but its preparation. The surfaces where it rests on the side jambs are not rough or uneven. They have been carefully dressed to be perfectly flat, creating a stable, level bearing for this tremendous weight. This attention to the contact point is a critical detail. It shows the builders were thinking about load distribution and structural integrity, ensuring the giant stone would not shift or crack under its own mass over centuries. Above this lintel, the famous triangular relief is carved directly into another massive block. This sculpture of two confronting lions, their forepaws resting on a stylized altar, is more than just decoration. It serves a brilliant structural purpose, relieving the weight of the masonry above from the center of the lintel below. But look at its fit. The triangular stone is not crudely wedged into place. It is precisely shaped to occupy the space created by the corbelled walls above the doorway. a perfect geometric solution carved with confidence. The surrounding walls, famously described as Cyclopean because later Greeks believed only giants could have moved such stones, tell a similar story of advancing skill. While the blocks are colossal and irregular, their faces show clear signs of being worked. They are not just found boulders. The surfaces have been squared and dressed, the edges knocked into a more defined shape to improve the fit. The joints, while not as impossibly tight as at Sacsayhuamán, show a clear intent to minimize gaps and create a stable, interlocking pattern. This marks a significant transition. It reflects a culture moving beyond simply piling huge rocks for defense toward a conscious refinement of stoneworking. The precision in the lintels' bearing surfaces and the fitted relief suggests the development of improved tools, perhaps harder bronze alloys, and more sophisticated techniques for measuring, shaping, and finishing hard limestone. The Lion Gate is a powerful declaration. It announces that its builders possessed not only the strength to command megaliths, but the growing technical knowledge to fit them together with purpose and an eye for enduring form, setting a standard that would echo through the classical world to come. Legends speak of a city that returned to the sea, a kingdom of gold and pillars swallowed by the waves as its divine protector departed. This is the story of Dwarka, the ancient capital of Lord Krishna in Hindu tradition, described in sacred texts as a magnificent, fortified city of great wealth and splendor, eventually claimed by the ocean. For centuries, these accounts were considered purely mythological, a symbolic tale rather than a historical record. Then, in the late 20th century, marine archaeologists began to look beneath the waves off the coast of modern-day Gujarat. What they found has reignited an ancient debate. Scattered across the seabed in the murky waters of the Arabian Sea lie the silent remains of a sunken world. There are not just random stones but clear structural formations. Sonar surveys and diving expeditions have mapped out what appear to be the foundations of walls, geometric layouts of large stone blocks, and the stumps of pillars, all resting in layers of sand and silt. The scale is significant, suggesting a substantial settlement, not a small fishing village. While centuries of tidal action and marine growth have eroded the surfaces, a closer examination of some of these submerged stones reveals telltale signs of human work. Several of the larger blocks show evidence of having been dressed, their shapes intentionally squared. More compellingly, a number of stone artifacts recovered from the area feature perfectly circular holes bored straight through the material. These drilled cores, though worn by time and water, echo the technological signatures we have seen in places like Puma, Punku, and Karnak. They point to a deliberate, precise process, not natural erosion. If these ruins are indeed the physical remnants of a historical Dwarka, they transform the legend into a potential chronicle of a real cataclysm. The precision implied by the worked stone aligns perfectly with the ancient descriptions of a magnificently constructed city. It suggests the builders were not primitive coastal dwellers, but a sophisticated maritime civilization with advanced knowledge of stoneworking and urban planning. They would have possessed the engineering skill to erect grand structures and the naval capability for trade and defense, thriving along the Indian coast thousands of years ago. The submerged stones of Dwarka, therefore, serve as a powerful bridge. They connect the vivid tapestry of myth with the tangible, if corroded, evidence of a lost chapter. They ask us whether the story of a great city falling into the sea is not an ending, but an invitation to look deeper where history rests not in books, but in the quiet, sandy darkness, waiting for its story to be pieced back together, one precise, drilled hole at a time. The bluestones of Stonehenge hold a secret in their quiet, enduring geometry. While the towering Sarsen circle commands the skyline, it is these smaller, imported pillars that reveal the subtle, technical ambition of the builders. Transported over 150 miles from the Preseli Hills in Wales, each bluestone is a monumental journey made solid. But their true story is not just in the distance traveled, it is in the careful shaping that awaited them on Salisbury Plain. These stones are not simple, unworked monoliths. They are crafted components made from dolerite, a rock so hard it rings like metal when struck. Upon close inspection, some of these bluestones bear the hallmarks of sophisticated joinery. Archaeologists have identified mortise and tenon joints, where a protruding knob, the tenon, was carved on the top of one stone to fit snugly into a hollow socket, the mortise carved into the bottom of another. This is woodworking logic applied to igneous rock, a technique designed to create stable, interlocking structures that could withstand the centuries. The precision lies in the exacting creation of these features, carving a perfect, rounded tenon or a smooth, cylindrical socket into unyielding dolerite with only stone hammers and antler picks seems a task of almost absurd difficulty. The process would have been agonizingly slow, a testament to a culture's unwavering dedication. The accepted method involves a technique called pecking, where a harder stone hammer is used to crush the surface grain by grain, followed by endless grinding with sand and water to smooth the form. Some researchers propose an even more advanced step, the strategic use of heat. By building controlled fires against specific areas of the stone, the surface could be thermally shocked, making it more brittle and easier to work, allowing for more precise shaping. This slow, deliberate removal of material, this patient abrasion guided by a clear mental template, is in its essence a primitive form of machining. It was subtractive manufacturing on a geological timescale where the tool was time itself and the blueprint was a ceremonial vision. Each perfectly shaped joint served a purpose beyond mere construction. It was a physical prayer, an act of aligning the earthly with the celestial, ensuring that this ring of imported stone would stand not just as a monument, but as a perfect, locked mechanism for ritual, echoing with the silent click of stone fitting into stone. Deep beneath the rolling hills of Zhejiang province lies a world that feels utterly removed from the rhythms of the sun. The Longyu grottos are not natural caves, but a labyrinth of colossal, hand-carved chambers that plunge into the sandstone bedrock. To step inside is to enter a space of unnerving order, a subterranean cathedral whose construction defies both logic and historical record. The sheer scale is overwhelming, with the largest cavern spanning an area greater than a modern sports arena, its ceiling supported by monumental, evenly spaced pillars left standing as the rock around them was removed. What is truly mesmerizing, however, is the texture of the walls. Every single surface, from the soaring ceilings to the vertical walls and even the massive pillars themselves, is covered in a uniform pattern of parallel chisel marks. These are not random, haphazard strikes. They are a consistent, angled series of grooves, each about the width of a hand, sweeping across the stone in a precise, rhythmic arc. This pattern covers thousands upon thousands of square meters, a repetitive, all-encompassing signature left by the tools of the builders. The unvarying nature of these marks is the key to the mystery. It suggests the work was not performed by countless individuals, each using their own technique, but was instead governed by a strict, standardized method. The angle of the chisel, the depth of the strike, the spacing of the grooves all appear regulated, as if the workers were following a specific, repetitive procedure. This points to a form of large-scale, organized machining. Imagine teams of laborers, each trained in the same motion, using identical tools, working in coordinated shifts to methodically strip away the bedrock layer by layer, their collective effort leaving behind this monolithic, mechanical texture. The purpose for excavating such an immense, perfectly finished underground space, consuming an estimated 1 million cubic meters of stone, remains one of China's greatest archaeological enigmas. There are no inscriptions, no artifacts, no historical texts that mention its creation. It is a space of pure, silent function, a colossal empty vessel waiting for a meaning we have lost. The Longyu grottos stand as a monument not to art or empire, but to process itself, a frozen snapshot of a disciplined, almost industrial excavation, where the very walls tell a story not of kings or gods, but of the relentless, patterned motion of tools guided by a single, forgotten intent. The ruins of Hampi in southern India whisper a different kind of stoneworking mastery. Here, amidst the sprawling remnants of the Vijayanagara Empire, you do not find towering walls or cyclopean foundations. Instead, you encounter objects of profound utility, transformed into works of art. Scattered across the site are colossal vats and troughs, each one carved from a single, massive block of granite. These are not rough-hewn basins. They are monolithic vessels of breathtaking delicacy and strength. Some are large enough to hold several people, intended for ceremonial use, for storing water, or for the preparation of festive foods. Their forms are elegant and balanced, with gently curving sides that rise from a solid base. The exterior is often adorned with intricate bands of carved decoration, patterns of lotus petals and geometric motifs that wrap around the stone like fine jewelry. Yet the true marvel lies within. The interior of these granite vats is a study in controlled subtraction. The craftsmen did not simply chip out a bowl. They carefully, patiently hollowed out the solid boulder to create a vessel with remarkably thin walls. The interior surface is not pitted or irregular, but is smoothly polished to a soft sheen, a finish that feels almost liquid to the touch. This is where the technical mystery deepens. Granite is a crystalline, unforgiving material. It does not bend or flex, it fractures. To take a solid block and hollow it out, leaving walls that are both thin and uniform without causing a catastrophic crack, is an operation of immense precision. It requires a deep, intuitive understanding of the stone's internal stresses and grain. The process likely began with careful heating and cooling to weaken specific areas, followed by a methodical removal of material from the center. But the final shaping, the creation of that smooth, even curvature and consistent wall thickness, points towards something more advanced. It suggests a technique akin to turning or milling. Imagine the massive granite block being slowly rotated, while a fixed cutting or grinding tool was applied to its interior, gradually scraping away material in a controlled, circular pattern. This method would allow for perfect symmetry and an even wall, something nearly impossible to achieve through random chiseling from a stationary position. Whether through a primitive lathe-like mechanism or through a disciplined, rotational grinding process, the artisans of Hampi displayed a machining mindset. They treated the granite not as a static rock to be beaten into shape, but as a workpiece to be precisely sculpted from the inside out. These silent vats, now empty and still, are not just containers, they are hollowed proofs of a forgotten dialogue between human intention and the very heart of the stone. But the true precision of Tiwanaku is not just in the fitted stones, it is etched into the face of its most famous icon. The Gate of the Sun stands alone, a monolithic portal carved from a single block of andesite, a stone so hard it defies casual work. From a distance, it is a masterpiece of mythology, its surface dominated by the central figure of the so-called staff god, surrounded by rows of winged attendants. Yet, step closer and the artistry gives way to engineering. The entire tableau is executed in low relief, meaning the designs are carved just slightly raised from the flat background. What is astonishing is the consistency. The depth of every carved line, from the god's elaborate headdress to the smallest feathers on the attendants, is remarkably uniform. There are no wavering strokes, no areas where the chisel slipped and cut too deep. This evenness suggests the carvers were not working free, and with a hammer and chisel, where natural variations in force would create an uneven profile. Instead, it points to the use of a guided tool, perhaps a kind of scribe or router that could maintain a fixed depth as it traced the intricate patterns across the stone's face. This transforms the gate from a sculptural monument into a technical artifact, a product of controlled, repeatable process. But the precision does not stop at the artwork. Look at the gate structure itself. The massive lintel is pierced by a series of perfectly square and round holes, and its sides are channeled with straight, narrow grooves. These are not decorative. Researchers have long debated their function, with compelling theories suggesting they formed part of an astronomical sighting device. Certain grooves and sightlines may have been aligned to capture the first rays of the sun on specific solstices or equinoxes, turning the gate into a giant stone calendar. Another theory proposes these features were part of a locking or pivoting mechanism, implying this massive stone was once part of a larger, movable apparatus. This shifts our understanding entirely. The gate of the sun may not have been a static doorway, but a dynamic component, a precision-cut piece of a much grander instrument. The even lines of its carvings and the exact angles of its holes speak of a culture that viewed stone not just as a canvas for myth, but as a material for building calibrated machines, a single, silent testament to a world where art, astronomy, and advanced toolmaking were seamlessly woven into one andesite block. Yet the vision of a perfect, polished obelisk finds its most dramatic and humbling contrast in the very place where such dreams were born. In the sun-scorched granite quarries of Aswan, a monument of failure holds more answers than a dozen finished triumphs. Here lies the unfinished obelisk, a colossal shaft of pink granite that never left its cradle of bedrock. It is a frozen moment, a 1,200-ton lesson in how the impossible was attempted. The giant form is clearly outlined, with workers' trenches cut deep into the stone around it, isolating this potential giant from the living rock. Within these trenches, you can still find the evidence of the primary method. Countless rounded stones of dolerite, a rock harder than granite, litter the site. These are the pounders, the tools of brute force. Teams of workers would have swung these stones in a relentless, rhythmic pounding, literally pulverizing the granite grain by grain along predetermined lines to free the obelisk. It was a process of staggering patience and physical toll, but to see only the brute force is to miss the deeper message. Look at the shape they were creating. The obelisk's sides, though rough, already show the precise, inward taper that defines these iconic monuments. The envisioned final product was not a rough pillar. It was a needle of stone, a geometric form requiring perfect symmetry and sleek, angled planes. This is the critical insight. The pounding with dolerite balls was only the first crude phase. It was the quarrying method, the way to liberate a raw blank from the earth. What happened next, had they finished, is where the true mystery lies. Taking this rough 1,200-ton blank and transforming it into a smooth, gleaming obelisk would have required a second, far more delicate stage of work. Every hammered surface would need to be ground flat, the angles made crisp and true, the entire surface polished to a reflective shine. This finishing process on such a scale, moving from a pounded surface to a machined one, implies the use of abrasives, guided grinding tools, and sophisticated measuring systems to ensure the taper was even on all four sides. The abandonment, likely due to a fatal crack discovered in the stone, is our great fortune. It allows us to witness the starting point, the raw extraction, and to comprehend the monumental leap that would have followed. The unfinished obelisk is a two-part story written in stone. First, the undeniable evidence of immense human labor, and second, the silent implication of a lost finishing technology that would have turned this mountain of rock into a razor-sharp beam of light. But the most profound evidence of this subtractive precision lies hidden beneath the streets of a modern town. On the Mediterranean island of Malta, a chance discovery in 1902 revealed a world that had been sealed for millennia. The Hal-Saflieni hypogeum is not a built structure, it is an excavated one, a sanctuary of death and ritual carved directly into the soft Globigerina limestone, descending 3 stories into the earth. To walk its dimly lit passages is to move through a mirror world, a perfect inversion of the megalithic temples that stand above ground on the island. The architects did not simply dig caves, they carved architecture. They reproduced the forms of their surface temples underground, with pillars, archways, and trilithon doorways all meticulously sculpted from the living rock. There are carved stone ceilings that mimic roofing slabs and false windows that look out onto solid limestone walls, a breathtaking illusion of space created through pure removal. The walls and ceilings are not rough-hewn, they are smoothly finished, presenting a uniform, almost plaster-like surface that speaks of a final, careful polishing stage. This consistency across 3 entire subterranean levels is the first clue to an organized methodology. It suggests the work was not haphazard, but followed a master plan, executed with a disciplined, repetitive process that could maintain the same standards of finish from the uppermost chamber to the deepest oracle pit. The tools available, as understood by archaeology, were simple antler picks and stone hammers, yet the result is anything but primitive. The control required to carve a perfect corbelled arch or a smooth, curved apse from the ceiling with such basic implements points to a cumulative, generational knowledge of the material, a tradition of stoneworking so refined it turned subtraction into an art form. But the hypogeum holds another, more ethereal kind of precision. One particular chamber, known as the oracle room, possesses extraordinary acoustic properties. A deep voice spoken into a small, carved niche in the wall resonates throughout the entire room with a powerful, vibrating hum that seems to fill the very bones of the listener. This is not an accident of geology. The shape of the chamber, the angles of the walls, and the specific placement of that niche were almost certainly designed to create this effect. It represents an early, intuitive understanding of sound wave propagation and resonance, turning a stone room into a ritual instrument. The hypogeum, therefore, stands as a dual monument to ancient precision. In its physical form, it showcases a machined approach to space, where rock was removed to exacting specifications to create a sacred replica of the world above. And in its invisible sound, it demonstrates a calibration of environment, proving that its creators sought to control not just sight and touch, but the very atmosphere of ceremony itself, engineering an experience that would resonate through both stone and spirit. The final whisper of this ancient precision is not carved in stone but held in the palm of your hand. In the ruins of the Assyrian palace at Nimrud, in modern-day Iraq, archaeologists uncovered an object that seems to belong to another age. It is a piece of perfectly clear rock crystal, carefully ground and polished into a convex oval lens. This is the Nimrud Lens, a small artifact that casts a long shadow over our understanding of the past. Dated to over 2,700 years ago, it is not a jewel or a simple ornament. Its shape is deliberate, a plano-convex form, flat on one side and gently curved outward on the other, ground with a symmetry that speaks of controlled intention. When you hold it to the light, its purpose becomes apparent. This lens has measurable optical properties. It can magnify small objects, bringing fine details into sharper focus. It can also concentrate rays of sunlight into a bright, hot point. The implications of this are quietly profound. Creating such a lens from rock crystal is an exercise in microscopic precision. Crystal is a form of quartz, a hard and brittle material. To shape it into this specific curved form without shattering it, and then to polish it to flawless optical clarity, requires more than a steady hand. It demands a systematic process. Artisans would have had to grind the crystal against a curved, abrasive surface with meticulous, even strokes, constantly checking the curvature, then progressed through finer and finer abrasives until the surface was perfectly smooth and free of scratches that would distort the light. This is lapidary work of the highest order, a form of precision machining on a tiny scale. It proves that the ancient drive for exactness was not confined to the monumental. Alongside their temples and fortresses, these cultures were also mastering the manipulation of light and vision. Was it a magnifying glass for a skilled artisan, used in fine detail work like seal carving or intricate metalwork? Was it a burning lens, a tool to kindle sacred fires, or could it have been part of a simple optical device, a precursor to the telescope used for observing the stars? We may never know its exact purpose, but its existence is a testament to a scientific curiosity intertwined with supreme craftsmanship. The Nimrud Lens is a quiet revolution in miniature. It reminds us that the fingerprints of a lost technology are not always giant. Sometimes the most compelling evidence is a small, polished window, a crystal-clear idea held up to the light of history, focusing our view on a past that saw the world with a sharper eye than we ever imagined. These scattered sites from the Andes to the Nile begin to form a startling constellation. When you step back from the individual mysteries, a clear pattern emerges, etched not in one stone but in dozens. It is a pattern of choice, method, and obsession. First, there is the consistent selection of the most challenging materials. Culture after culture gravitated toward granite, andesite, basalt, and quartzite stones of immense hardness that laugh at soft copper and bronze. Why choose the most difficult path unless you possess the means to walk it? Then we see the recurring technical signatures, the spiraling groove of core drills, the parallel striations of straight saws, and those impossibly tight, mortarless joints that seal stone to stone with a perfection that defies time and tremor. These are not artistic styles, they are manufacturing fingerprints. They point to a shared understanding of principles of rotational force, guided linear cutting, and precision measurement. This consistency across continents and millennia whispers of a shared technological language. It forces a difficult question upon us. Were these disparate cultures, separated by oceans and centuries, all independently stumbling upon the same advanced solutions to working stone? Did the Incan master, the Egyptian artisan, and the Tiwanaku engineer each, through their own isolated genius, reinvent the same methods of core drilling, surface milling, and seismic joinery? It is possible, but the uniformity of the evidence makes it feel like more than coincidence. It suggests the alternative, a diffused knowledge base. Perhaps this high craft was not invented anew in every mountain valley, but was instead a technology that traveled, carried along forgotten trade routes, or preserved by a lineage of master builders who served kings across the ancient world. This leads to the grander, more speculative possibility, a common source. Could there have been a foundational civilization, now lost to the deep past, whose mastery of stone became the template for all who came after? Their legacy would not be a single city, but a set of techniques, a toolbox of precision that survived the collapse of its original owners and was adopted, adapted, and imperfectly remembered by the cultures we now call ancient. Whether through independent innovation or a shared inheritance, the pattern is undeniable. Our current historical models, built on a gradual progression from simple to complex, strain to contain this evidence. The stones tell a story of a capability that appears fully formed in the archaeological record, demanding we expand our understanding of humanity's technical journey. They ask us to consider a past where the line between hand tool and machine was far blurrier, and where the drive for perfection in stone may have been one of our oldest and most forgotten sciences. The polished lens from Nimrud focuses a difficult question into sharp relief. What do we do with this mountain of anomalous evidence? The stones do not lie, but their story challenges the one we have written for ourselves. Mainstream archaeology, built on careful excavation and analysis of surviving artifacts, offers a powerful and persistent answer: human ingenuity amplified by immense organized labor and time. The official narrative tells us these wonders were born from the sweat of thousands, wielding simple copper chisels, stone hammers, and abrasive sand, working across generations with a patience modern society can scarcely fathom. This view emphasizes social organization, the power of religious belief to motivate labor, and the incremental refinement of techniques over centuries. It is a story of cultural triumph, of humanity bending nature to its will through sheer persistence, and for many sites, this explanation holds a profound truth. The patience of our ancestors was indeed a form of technology in itself. Yet, standing before the mirror finish inside a 70-ton granite box or tracing the perfect spiral inside a drill hole, that explanation can feel incomplete, like trying to describe a symphony solely by counting the musicians. The gaps in the practical how lead some researchers to look for answers in the realm of the extraordinary. Alternative theories propose grand, sweeping narratives of lost worlds. They point to the legends found in cultures across the globe, stories of a great flood, of a golden age, of a sophisticated civilization that fell beneath the waves or was wiped clean by a cosmic cataclysm. Could places like Atlantis or Lemuria be not mere myth, but distant, garbled memories of a precursor culture? This idea suggests that the precision stonework we see is not an invention of the Egyptians or the Incas, but an inheritance, a surviving toolkit from a much older society that mastered these arts before disappearing, leaving only their most durable works behind as puzzles for their successors. Another compelling thread suggests these ancient builders possessed not a lost civilization, but a lost science. This middle path seeks a technical explanation that still resides within the realm of human achievement, but of a kind that has not survived in the archaeological record. What if their tools were not simple but brilliantly sophisticated? Theories explore the possibility of advanced chemistry, plant extracts or mineral compounds that could temporarily soften stone, allowing it to be molded or shaped more easily. Others delve into the physics of sound, proposing that specific resonant frequencies could have been used to vibrate stone at a molecular level, making it malleable. There is also the persistent idea of forgotten metallurgy, that ancient smiths could produce alloys far harder than the basic bronze and copper we have found, alloys that could have been the teeth of saws and the tips of drills, tools that were so valuable they were melted down and recycled, leaving no trace for modern excavators. Perhaps the most satisfying answer lies not in choosing one extreme over the other, but in redefining what we mean by ancient technology. We must let go of the modern assumption that a machine must be made of steel and powered by electricity. What if the greatest machine was a perfectly trained human society, guided by a sacred geometry and generations of accumulated empirical knowledge? The true innovation may have been a seamless system that combined simple mechanical principles, levers, sledges, and water, with a profound, almost intuitive understanding of materials. Their religious and political will provided the unshakable power source, their ritual precision provided the calibration. In this light, the line between a hand tool and a machine blurs. A bow drill becomes a precision lathe when used with a master's touch and a standardized template. A team of workers pulling a granite saw becomes a living, breathing milling apparatus when their movements are synchronized to a chant or a drumbeat. They achieved machining-like results through a fusion of art, science, and social organization that we are only beginning to comprehend. This is not about discrediting the awe-inspiring labor of the past, but about expanding our appreciation for its sophistication. The evidence carved into these 30 sites invites us to consider a more nuanced history, one where human capability reached peaks that were later forgotten, not through catastrophe, but perhaps through the slow erosion of specialized knowledge after a project's completion. It asks us to look at a perfectly fitted joint and see not just a stone, but the shadow of a master's mind, a mind that solved problems of physics and engineering with a toolkit far more elegant and complete than we have ever given them credit for. The mystery, therefore, is not a barrier to understanding, but an invitation to look deeper, to grant our ancestors the full measure of their genius, and to wonder what echoes of that lost precision might still be waiting for us to rediscover. The stones have spoken, and their story reshapes the landscape of our past. This journey across continents and millennia reveals a world far more technically adept than our textbooks often allow. From the spiraling drill cores in Egyptian granite to the interlocking polygonal puzzles of the Andes, the evidence is not ambiguous or open to simple interpretation. It is etched in stone with a silent, undeniable clarity. These are not random anomalies or artistic flourishes. They are systematic clues pointing toward a deeper, more complex human narrative, one where precision was not a later invention, but perhaps a foundational skill. This consistent pattern of impossible joins, machined surfaces, and worked materials of immense hardness challenges the comfortable, linear timeline of progress. It asks us to reconsider the very definition of ancient technology, to see in these monuments not just the product of immense labor, but the shadow of immense knowledge. The true value of this evidence lies not in proving a single, lost civilization, but in expanding the boundaries of what we believe was possible. It invites a more humble and curious approach to history, where the artifacts themselves guide our questions rather than conforming to our existing theories. These sites stand as permanent invitations to keep questioning, to keep exploring, and to refine our understanding of who we were. They remind us that the past is not a closed book, but an ongoing excavation, and that the most profound secrets are often those left in plain sight, waiting for us to look with new eyes. Which of these sites holds the most compelling evidence for you? Does the flawless geometry of Puma Punku speak loudest, or does the submerged mystery of Yonaguni capture your imagination? Share your thoughts in the comments below. If this exploration of ancient mysteries and forgotten fingerprints has intrigued you, subscribe for more journeys into the unknown, where history and mystery continue to collide, revealing the extraordinary depths of our shared human story. This quest for understanding does not end with the final stone. The conversation around these ancient sites is alive and evolving, fueled by researchers who dedicate their lives to documenting these anomalies. To continue your own exploration, seek out the detailed work of engineers like Christopher Dunn, who applies a machinist's eye to Egyptian craftsmanship, or authors like Graham Hancock and Brian Forrester, who travel the globe compiling visual evidence and local lore that challenge conventional timelines. Their investigations, available in books and documentaries, offer a deeper catalogue of the precise marks and impossible fittings we have only begun to touch upon. For a more hands-on experience, visit the great museums of the world. Stand before their collections of Egyptian statuary or Greco-Roman stonework, but look beyond the artistry. Lean in close and examine the surface. Search for those telltale parallel striations, the faint spiral grooves in a drill hole, or the mirror-like polish on a granite surface. Let your own eyes judge the quality of the work. If the opportunity ever arises, consider traveling to these sites yourself. Walk the sunken passages of the Osireion, feel the seamless joints at Sacsayhuamán, or gaze up at the towering blocks of Baalbek. There is a profound difference between seeing a photograph and standing in the shadow of these wonders, allowing the scale and the silence to ask their own wordless questions. Your curiosity is the engine of this ongoing discovery. If this journey through 30 ancient sites has reshaped your perspective, let that engagement continue. Liking this video helps share these ideas with other thoughtful viewers. Sharing it with a friend who loves history can spark a fascinating conversation. And by hitting the notification bell, you ensure you will not miss our next investigation into the world's greatest enigmas, where we continue to piece together the hidden chapters of our shared story. The past is not a closed book, but an open field, waiting for anyone with a questioning mind to step into it and begin to look.